hopefully tie what you've just said together, or you've done a very good job already. So on this last diagram, you've got azimuth and altitude as you went through. But what you've also got, for whatever reason in this diagram, is this curve that they put in to show that this is a measured angle. Yeah. Now, again, they haven't labelled any 90s, but that's fine for what I'm about to use this diagram for. So if you imagine this is you, this is your light in the sky, and you're holding an angle measuring device to measure the angle. This is the angle. Here's the flat earth that you're using to measure that angle. There's the angle itself from the flat baseline through a protractor. So now imagine that this line is a protractor. Yeah, it's what you're using. You could mark from 0 to 180 on it. Yep. So you've got a semicircle. That semicircle is the projected point that you see in this diagram. This semicircle is part of this wedge. So on this diagram, the 10th Scott, these are great, by the way. You've got the same exact. Can you pop yourself on mute, whoever that is? You can see the same triangle that 10th pointed out. This triangle here for measurement of an angle from your observer position on a flat plane to a point on the ground 90 degrees to your position. This triangle is the same as this triangle. And this triangle is useful because it's got this section through that triangle that creates this view. So now your observer position is here with no hint of the actual flat plane surface that you're measuring the angle to, and no hint of a point on the ground, the extended equatorial plane that is used with these diagrams and these globes and these celestial spheres with you in the center of them. You still need, the whole point of it, an extended celestial plane if you're looking outside of this ball, or if you just look inside the ball, you've got an equatorial plane inside this ball for you to be standing on to put a 90-degree position to it on the ground, 90 degrees to your position in the center of hell. But that triangle, which is definitely not going to be shown in this diagram, is this triangle. So you're starting to see these layers sitting around, these sections. They're just sections of a protractor, if you want to think of them in that way. They're the projected points that would be projected out first to a ball, and then out to, if you count the point where you're seeing this light in the sky, this would be a second protractor around your position. And that would be the celestial sphere. So you've got what you're seeing from the ground with a globe wrapped around you, and then the celestial sphere wrapped around that. That's this. There's you. There's the ball. There's the celestial sphere. Here's the measured angle with the actual line to the flat earth ignored, because you've got all the projected points to use. Then you can start describing an observer's zenith. What's that? The point that the line goes up through you, through your head. You can put that up here on the celestial sphere. It's like, no, you're going to be down here if you're describing zeniths. They're going to be straight up. They're not going to be coming out at any strange angles. But this is how you project a ball. This is how you take an angle measurement from the ground and convert it to PZX triangles. That's how the globe's been created. So when we say the globe is created with flat earth measurements, this is what we're talking about. These are the diagram to sort of hopefully